in last class, we talked about the right angle trigonometry, right? Trigonometry, where we introduce the right triangle, the adjacent side, opposite side, and the hypotenuse, and how to use them to find the sine and cosine, tangent, cotangent, and all these trigonometric functions, right? So we have 6 of them, right? Sine, cosine, tangent, secant, cosecant, and cotangent functions, right? And then in the end, we also introduce how to use these trigonometric functions to solve some real life problems, like to find the length of the ladder, right? To find the height of a building and so on. Also in last class, we started a little bit about the unit circle, section 3, all right? So section 3, so we introduced this theorem, all right, it's given here, in a unit circle, right? In a unit circle centered at 0, 0 with radius 1, we have the arc length and also the coordinates of the endpoints, all right? So x is cosine t, y is sine of t. Now today we are going to continue with this one, all right? So we're going to learn more about this unit circle and this relation to the trigonometric functions. Okay, so now as we can see in this unit circle, x is cosine of t, y is sine of t. Y coordinate is sine of t, right? The corresponding angle measured in radian. Okay, so and x, the coordinate is cosine of t. All right, so this is always the same. Now, as you can see, since it is a unit circle, all right, it's a unit circle. So this one is 1, and here is what? -1, right? So as we can see, the x coordinate of all the points on the unit circle is between what?
1 and -1?
Yeah. X is greater or equal than 1, less or equal than, greater or equal than -1, less or equal than 1, right? So, and also we see that x equals cosine t. This is always true, right? So then this implies what? Cosine of t is in between -1 and +1. Does that make sense? Okay, yeah. And similarly, what about y? What is the range of y?
-1 to 1.
As well, right? So it's still -1 to 1 because it is a unit circle centered at 0, 0. So y is also in between -1 and +1. So this, since y is the sine of t, so we also have what? Sine of t is greater or equal than -1, less or equal than +1. Yes? Okay. Now, another thing about is, what about the value of t? Okay, the t. Now, t can be rotate. It's the angle, right? And it can take the, you can do several rotations, several full rotations, and then stop somewhere, right? Counterclockwise or clockwise. Does that make sense? All right, it's an angle, right? So it can be any angle that goes counterclockwise or clockwise. So counterclockwise is going to be positive. Clockwise is going to be negative, right? So but by that, these observations, we can see the domain and the range of sine and cosine functions. Okay, so what is the domain of sine and cosine functions? So sine of t, cosine of t, right? Cosine of t. The domain can be any real numbers, right? It can be positive or negative or 0. Okay, so that's the domain. It can take any values, either it's positive or negative, okay, or 0. But the range All right, as we can see, the range or the values, the possible set of possible values taken by the functions, right? They're what? Between -1 and 1. The range is the brackets, -1, 1, right? Okay, so that's the domain and the range of sine and cosine functions. Okay, now, based on this one, we also know, all right, what about the other functions? Okay, so for now, we are going to focus on sine and cosine. Okay, for now, we are going to focus on cosine and sine. Later on, we're going to talk about tangent and all the other all the other trigonometric functions. Okay, so for now, we're going to stay here. All right, so let's just consider an example here. Okay, Nick, can you read for us, please?
Yes, a certain angle t corresponds to a point on a unit circle at point square root of 2 divided by 2 and square root of 2 divided by 2. Find cosine t and sine t.
Very good. All right, very good. Okay, so let's do this one, right? So you may sketch this one, but let's just sketch this one. All right, so like this. All right, so this is the point. I know that's square root of 2 over 2, and this is square root of 2 over 2. Okay, okay, so right, so as we can see, this is my t angle, right? T. So for this one, because x is the x coordinate is square root of 2 divided by 2, and y is also square root of 2 divided by 2. So what is cosine of t? Cosine of t equals x or y?
X.
X. All right, cosine t equals x is x coordinate. Sine is the y coordinate. All right, equals x. And by x, we know it's the first entry, right? It's square root of 2 over 2. And sine of t equals y equals what? Again, square root of 2 over 2, but it's the second entry. Yes? Now, what if I give you another point? All right, somewhere here. Here is square root of 2 over 2. Negative. This should be negative, right? So when it is in the second quadrant, x value is negative. Yes?
Mm-hmm.
Negative square root of 2 over 2 and square root of 2 over 2. All right? It is negative. Okay? So in this case, t is what? Okay, t goes here, right? T is larger than the right angle. It goes to the second quadrant, right? Go to the second quadrant. So what in this case, say this is a t prime, right? Say this is t prime. So what is the cosine t prime?
In
Cosine
negative pi over square root of 2 over 2.
Yes. All right. Very good. Now, cosine t prime is again the x coordinate. Okay, is again the x coordinate. So for this one, let's say that x prime. Okay, so it's negative square root of 2 over 2. Okay, so and sine t prime equals what? Y prime equals square root of 2 over 2. Now, no matter what, okay, so the theorem holds. All right, cosine of t is the x coordinate. Sine of t is the y coordinate. Okay, just remember that. Okay. All right. Now let's consider another example here. Natalie, can you read for us, please?
Yes. A certain angle t corresponds to a point on the unit circle at square root of 3 over 2, negative 1/2. Find cosine t and sine t.
Very good. Thank you, Natalie. All right, let's do this one. Let's just sketch. All right, so I'm gonna do this. And how do you think? This is which quadrant is this t is?
quadrant
Fourth.
4, bottom right.
quadrant 4, right? Quadrant 4, because what? X is positive. It is somewhere here, right? So bottom right is, okay, so it might be something like this. Yes, okay, because Y is negative, X is positive, right? So it is somewhere here. So that's what? Square root of 3 over 2, negative 1 over 2. The angle is, right? This is our T. Okay, this is our T. Then we have cosine of T equals what? Equals, what is cosine of T?
3 squared over 2.
Yeah, square root of 3 over 2. And sine of T equals negative 1/2, right? Equals negative 1/2. Okay, so this is a pretty simple example, right? So we can see that this one for any angle, we have such a relationship. Now, cosine of T is X coordinate and the Y sine of T is the Y coordinate. But be careful, it is the unit circle. This is true for the unit circle. All right, this is true for the unit circle. Okay, now for other circles, if it is some other circle, this is not right. But make sure that this is in a unit circle and the point is at the unit circle. Now, let me just ask you another question. All right, so let me just ask you another question, see if you can solve this. Okay, so that I know that in the other way around, if the angle, all right, if a certain angle T, if T equals pi over 3. So pi over 3 or what? 60 degree, right? Or 60 degree. Now find the point on the unit circle corresponds to T. Find the point on the unit circle corresponds to that corresponds to. Can you find this one?
Would it be 1/2 over square root of 3 over 2?
Very good. All right. So I think that's right. Okay. So here it is going to be this point, right? We want to find out this point, correct? So T is 3 pi over 2, which is 60 degree. So it's something like this, correct? Now, for this one, as we know, we have X coordinate is cosine T, right? So we will know that X equals cosine pi over 3. Yes. So what is cosine pi over 3? Or cosine 60?
I just use the special angles.
Yes.
That's what I use.
Right. The special angle. In last class, we talked about this when we introduced an example about that. Do you remember that? In last class. All right. So cosine pi over 3 is 1/2. Okay. And Y equals sine pi over 3. Now, which equals square root of 3 over 2. Okay. So very good. So therefore, the point corresponds to that is going to be what? Here is 1/2 and square root of 3 over 2. That is the point. Does that make sense? So, and therefore, we know that, you know, if given a point, we can find the cosine sine, right? Now, given the angle, we can find the coordinates, right? So either way, we should know all these ones, okay? All right. So now let's consider another examples. All right. So finding sines and cosines of angles on an axis or on axis. This is something very interesting. Okay. So let me just draw this one here, and this is okay. So this is centered at 0, and this is cosine 0 and sine 0. What if we have the angle is 0? Angle is 0, so that's just aligns with this line, right? What is the intersection of x-axis and the angle? This point is what? A 1 and 0, right? So because this is, and the corresponding angle is 0, so what is cosine of 0?
0 would be x, which is 1.
Yeah, cosine of 0 equals 1. Now similarly, so what is the sine of 0? As gonna be the y coordinate, which is 0, right? Okay, very good. Now, and also they want to find a cosine pi and sine of pi. All right, cosine pi. So pi, as we know, that's the half circle, right? One whole full circle is 2 pi. So pi is going to be 1 half a semicircle. So it is, this angle is pi, right? So this angle is pi here. So what is the intersection? That would be what?
-1, 0.
-1. X is -1. Y is 0, right? So y is 0. Very good. So now for this one, so what is cosine of pi?
-1.
It's -1. Very good. And sine of pi is 0. Yes. Okay. Now, how about the other ones? So what about the say pi over 2, cosine pi over 2, sine pi over 2? If it is pi over 2, what is the intersection of this angle, this array? Will be what?
Be 0, 1.
Be 0, 1. All right. So pi over 2, it is goes to this place, right? Goes to this place. So, and this coordinate is 0 and 1. Okay. So cosine of pi over 2 is
0.
Is 0, and sine pi over 2 equals 1. Now, how about this one? That is what?
0, -.
3 pi over 2, right? Okay, that's 3 pi over 2. So this point is going to be 0, -1. Yes, 0, -1. Okay, so x is 0, y is -1, right? So cosine 3 pi over 2 equals what? Equals 0, right? And sine 3 pi over 2 equals -1. Okay, all right. So I think that's very interesting, right? Based on this unit circle, we can find out the sines and cosines of angles on the axis, right? Sine, cosine 0, sine, cosine pi, sine, cosine pi over 2, sine, cosine 3 pi over 2. Yes. Okay. And also you may also see some like the we also from these values, right? We find some interesting relations. Now, firstly is the co-function identity, right? So cosine 0 equals what? By cosine of 0 equals by co-function yes. Which is what? Sine pi over 2. Now we see that cosine 0 is 1, sine pi over 2 is 1. So they are indeed equal, and they're both 1, right? Now similarly, all right, sine of 0 equals what? Cosine pi over 2. Yes? Okay, they are both 0, right? well, for the other ones, we will talk about them later. All right. So now this one is we just discussed these ones. 3 pi over 2, 3 pi over 2, pi over 2, pi over 2. Yes. Okay. So all right. So now we are going to introduce the so-called Pythagorean identity using cosine and sine. All right. So usually the Pythagorean theorem is for any right triangle, right, with A, B, and C. We know that A squared plus B squared additional Pythagorean theorem. And for Pythagorean identity, so we are talking about, here we are talking about, it's in a unit circle. In a unit circle, right? So for instance, this is my T, and here is X and Y. I know that this is X and here is Y. Now, of course, we'll have X squared. This is a right triangle, right? This is right triangle. Square plus Y square equals, and since it's a unit circle, it is 1 square. Yes? Since it's a unit circle, the radius is 1, right? So X squared plus Y squared equals 1 square equals 1. Now, because X equals sine and Y equals sine of T, so by substitution, we have what? X squared plus Y squared is cosine squared. This one equals 1. Does that make sense? All right, so that's how we got this equation. All right, this is a Pythagorean identity. All right, so cosine squared plus sine squared equals 1. Now, of course, this also implies what? All right, cosine squared T equals 1 minus sine squared T. Yes? All right, because the summation is 1, so cosine is 1, subtract the sine from 1, right? And similarly, we will have what? Sine squared T equals 1 minus cosine squared T. All right, so they are equivalent. All right, they're equivalent. All right, so now let's consider some examples. All right, let's consider some examples here. Salim, can you read for us, please?
Given that sine t equal 3 divided by 7 and t is in the second quadrant, find cosine t.
Okay, very good. All right, very good. Okay, so for this question, let's firstly sketch this. Okay, so we know that sine of t is 3 over 7. All right, 3 over 7. So it is, and it's in the second quadrant, right? So it should be, it's a positive, sine t is a positive. So it is above, y is positive, right? Y is 3 over 7. So it is something like here, right? So the t is going to be what? Somewhere here, right? T, this is going to be our t. Now, we know that, all right, sine of t is 3 over 7. So y is 3 over 7, right? So here is x, here is y. Now y equals 3 over 7. Now we want to find the cosine of t. So cosine t is our x, correct? Okay. Now to find this one, we need to know, firstly, all right, what is the relation between cosine and sine using the Pythagorean theorem, right? So that's because the Pythagorean identity is their summation equals 1, and also we have what? These two equivalent equations, right? So given sine of t, we want to find cosine of t, right? So solution. Cosine of t, let's say that, all right, by Pythagorean theorem, let's see how to write it. Pythagorean identity, we have cosine of t squared equals 1 minus c equals what? 1 minus what? 1 minus 3 over 7 squared, right? So which equals, let me just, which equals 1 minus 3 squared is what?
9.
9. And the 7 square is
49.
49. Yeah, very good. So what is this? 40 over 49. Yes?
Hmm.
Okay. Now cosine square equals 40 over 49. Then what is cosine t?
It's
Now,
just square root.
it can be positive square root of 40 over 49, right? Or what? Or negative. Yes? Because
Oh, that's a possibility.
it is also possible to be negative, right?
Mhm.
Now, but for this question, we know that t is in the second quadrant. If t is in the second quadrant, what is the sign of cosine?
Negative.
Now, cosine is x, right? X coordinate, so here it should be negative, right? Now, here, since t is in the second quadrant, now cosine of t is less than 0. Okay, it's negative. All right, it's negative. Hence, cosine of t equals what? A negative square root of 40 over 49. That is negative square root of 40 over square root of 49. That's what? 7. Yes? Now, you can also write this one to one more step. All right, but it's not necessary. So 40 can be written as a 2 square root of 10 over 7. All right, if you want to simplify it, you do more, but it's not necessary. All right, it's not necessary. You may just leave it like that. Okay, or using a decimal point, using a calculator. Does that make sense? Okay. All right. This is how we solve this question. All right. You firstly sketch, right, the graph, and then using the Pythagorean find the square of cosine, right? Find the square. Now, then you have to be careful, right? Depending on the quadrant, the location of t, you need to determine the sign of cosine, right? Because t is in the second quadrant, as we can see, cosine is going to be negative, right? Cosine is less than 0. So then cosine t equals negative square root of this. Okay? Any questions on this part? Right? All right. Let's move on to another one. Okay, Mustafa, can you read for us, please?
Given that cosine t equals 24 over 25 and t is in the fourth quadrant, find sine t.
Very good. All right, let's do this one. Okay, let's do this one. Let's again sketch. Right. Cosine t is 24 over 25. That's pretty close to positive 1, right? Pretty close. And it's in the fourth quarter, right? It's the fourth quadrant. So sine should be below the somewhere here. So t is what? This is t, right? So t is in the fourth quadrant. So goes this way. Okay. Now, what is here is what? You may just write cosine t sine of t, right? So this is going to be cosine of t sine of t. So can you find out what is cosine sine? What is sine t, please? Go ahead and see if you can find this. Okay. Okay, all right. Let's do this one together. Anybody found the this one? So let's do this one together. All right. So by Pythagorean identity, we have sine of t squared equals 1 minus cosine t squared equals 1 minus 24 over 25 squared, which is 1 minus this one, right? 1 minus this one. You can use the calculator to find out. All right. So this should be what? 25 over 625. Did you got this? Or
I got
we got some,
different.
okay, we got something different. Okay, so let's do this one together. All right, so this is going to be 25 square over 25 square minus what? 24 square over 25 square, right? So equals 25 square, 25 square minus 24 square. So it should equals what? What is 25 square minus 24 square is what? Oh, 49, right?
Yeah.
Oh, yes, 49 over 625. Sorry, my bad. I made an error. Okay, cool. Thank you. That's very good. All right, so this should be a square root of, this is 49. I forgot to add them up. Okay. All right, so this one is going to be, instead of this one is 7 over 25. Yes, this looks better, right? Okay, very good. All right, so sine of t is negative 7 over 25. All right, sine of t is negative. Okay, so be careful in the calculation, right? So sorry, I made an error here. Okay, so it's negative 7 over 25. Okay, all right. Now let's just review this one, right? So basically what we do for this type of equation is using the Pythagorean identity, right? Given cosine, we can find the square of sine, right? By using this identity. And then you need to determine the sine of sine, right? Of sine t. Because the location of t, due to the location of t is in the fourth quadrant, we know that sine t is going to be the y coordinate, which is less than 0. Since it's less than 0, sine of t is a negative square root of that. Okay, so we found that. Okay, so just be careful on these type of questions. All right. Now here are a summary of special angles. All right, a summary of special angles. Like the angle, if angle is 0, all right, cosine of 0, as we see, is 1, 0, right? So if the angle is 0, it's 1, 0. So cosine is going to be 1, sine is going to be 0. Yes? Now, if it is a pi over 6 or 30 degree, it is this coordinate. So cosine is going to be square root of 3 over 2. Sine is 1/2, right? Because sine is the y coordinate, right? And if it is 4 pi over 4, so which is here, right? So the x, y coordinate are both square root of 2 over 2. So in this case, the cosine and sine are both square root of 2 over 2. And if it is t equals what? Pi over 3, all right, then we have cosine is 1/2, sine is square root of 3 over 2. Finally, if it is a pi over 2 or 90, which is a right angle, then we see the intersection is 0 and 1. So cosine is 0, sine is 1. Right? So here is a summary of these special angles, Okay? Now later on, by special angles, we mean it's multiples of pi over 6 and pi over 4 and pi over 2. Okay, so something like that. Okay, so here, calculator tips. Actually, we discussed this one in last class. All right, we're going to skip this one. This is to try to find the sine of t, cosine of t. All right, using the calculator, right? So we did this one in last class. Now then we are going to do something about the reference angles. Okay, so this is a new concept. This is a new concept. So what is a reference angle, right? So a angle's reference angle. Okay, it is corresponds to an angle. An angle's reference angle is the measure of the smallest positive acute angle, theta prime, formed by terminal side of the angle theta and the horizontal axis. Okay, so let me just sketch in different situations. Now, if the angle is theta, it is somewhere here. If theta is acute, all right, in the first quadrant, right? It's in the first quadrant. Then we will have what? With x-axis, this is a y-axis. So of course, this is just the reference angle is just it itself, right? So in this case, theta prime equals theta. Yes, if it is in the first quadrant. Now, if it is in the second quadrant, this is theta, right? If this is theta, then what is the smallest positive acute angle formed by the terminal side? This is the terminal side and the horizontal axis. The horizontal axis is x-axis, right? X-axis. So this one will be what? Theta prime, right? This one will be theta prime, right? So theta prime is the acute as positive and smallest. So in this case, what is theta prime? It is, I believe it is a half circle minus theta, right?
Mhm.
So that's what? Pi minus theta. Because pi is a half circle, right? Pi is a half circle. So pi minus theta. This is if what? If theta is in the second quadrant. And similarly, if it is somewhere in the third quadrant, now this is theta, then theta prime is going to be what? This is theta prime, right? Now in this case, what? Theta prime equals what? Actually, it's subtract from subtract pi from theta, right? So it's theta minus pi. Yes, it's theta minus pi. And finally, okay, finally, if it is in the fourth quadrant, this is theta, right? This is theta. Then my theta prime became what? Become this one. So theta prime equals what? 2 pi minus theta. All right, equals 2 pi minus theta. Of course, here I'm talking about when theta is between what? 0 and 2 pi. All right, when theta is between 0 and 2 pi. Now for other thetas, all right, you have to what? Find the coterminal angle within this range from 0 to 2 pi. All right, and then based on these ones, find the based on these different situations, find the corresponding reference angle. Okay, but for theta between 0 and 2 pi, now if it is in the first quadrant, they're equal. In the second, pi minus theta. Third, theta minus pi, and the fourth is 2 pi minus theta, right? Okay. Now, of course, we are doing this using radians, right? So if you are using degrees, then pi will be 180, 2 pi will be 360, right? 360 degrees. Okay. All right. So let's summarize these procedures. All right, these procedures. Now, given angle between 0 and 2 pi, we find its reference angle using the following steps. Okay, so if the angle is in the first quadrant, it's its own, right? So this is theta prime equals what? Theta, right? Equals theta. Second, if in the second or in the third quadrant, the reference angle is the absolute value of pi minus t. All right, so remember, if in the second one, the theta equals pi minus theta, right? Now, if it is, but this one is the same as what? The absolute value, right? Because what? It is positive, right? If it is in the second, pi minus theta is positive, so it equals absolute value. Now, if it is in the third quadrant, then it equals theta minus pi, which is negative pi minus theta, right? Now, which equals what? The absolute value of pi minus theta. Because pi minus theta became negative, the absolute value of a negative value is negative, is positive. Now, in both cases, it equals what? Absolute value of pi minus theta. Okay, so, or you can use t, right? If you can use t, all right, t if t is the angle, okay? Now, for the third case, for an angle in the fourth quadrant, the reference is 2 pi minus t, like we did, right? Like we did here. Okay. Now, finally, this is an angle between 0 and 2 pi, right? 0 and 2 pi. Now, for other angles, if an angle is less than 0 or greater than 2 pi, what we do is add or subtract 2 pi as many times as needed to find an equivalent angle. So here equivalent means what? Coterminal. Coterminal angle between 0 and 2 pi, and the reference angle of the equivalent angle is the reference angle of the angle. Okay, and now you can just apply this three and find the reference angle, and that reference angle is the reference angle of the angle. Okay, so now I'm going to demonstrate this procedure using several examples and make sure that you understand what we mean. All right, so let's just consider some examples here. So Joshua, can you read for us, please?
Find the reference angle of the following angles: 43 degrees, 2, 190 degrees, and 330 degrees.
Very good. All right, thank you, Joshua. Okay, so let's do this one together. Okay, A. Now 43 degree. Which quadrant is it in?
The first one.
The first one, right? So 43 is in the first quadrant. The reference angle is, okay, I'm going to just I'm going to let theta prime represents the reference angle, all right, reference angle. Okay, then theta prime is simply what? All right, using here, if in the first angle quadrant, it's own reference angle, theta prime equals 43 degrees. Yes?
Mm-hmm.
Okay, now B. What is the, where is the location for 2? 2 is measured in radian, all right? There's no unit here, so 2 is in radian. Is 2 in which quadrant?
Maybe second,
Why it is the second one?
because half a circle is pi, and then pi divided by 2, which is 90, is like 1.5 something.
Very good. All right, very good. Okay, so since what? Okay, since. Okay, so since 2 is greater than pi over 2. Yes? Pi is 3.1, right? So of course pi is less than 4, so 2 is greater than pi over 2 and less than what? Less than pi.
Pi.
Yeah. So it is in the second quadrant. Right? It is in the second quadrant. Now, if it isn't in the second quadrant, what is the reference angle? All right. So it's square root, the absolute value of pi minus theta, right? Pi minus t. So theta prime equals what? Absolute value of pi minus 2. Now it is pi minus 2 because pi is greater than 2, right? It is pi over 2, pi minus 2. Okay, so, and C. What about C, 190 degree? Is that in which quadrant?
The third,
The third. Why?
it's past 180 degrees.
And less than what?
270.
Less than 270, right? So this is in the third one, right? Since 180 degree is less than 190, is less than 270. It is in the third one. Right? So theta prime equals what? Absolute value of pi, but not pi, right? Since this is already in degrees, right? So it is 180 minus 190. Absolute value, right? So it's absolute value of what? Negative 10. So if you take the absolute value, what is that?
10.
That's 10 degrees. Yes?
Mhm.
Okay, so this is using the second, right? So because it is in the third quadrant, the reference angle is the absolute value of the difference, pi minus t. So we got that. And finally, let's consider d. So which quadrant is 330 degrees?
In the fourth.
Yeah, it's the fourth one, right? So because it is greater than 270 and less than 360, right? So 30 is greater than 270 and less than 360 is in the fourth quadrant. So what is theta prime?
360 minus 330.
Yes, 360 minus 330. And not absolute value, just 360 minus that. Okay, sorry. It equals 360 minus 330 equals 30 degree. Okay, so that's what we get. All right, so that's how we got this. Right. Basically, based on their quadrant, we can find out using the formulas, right? So we can find a reference angle. Okay, so now this example, it contains all the angles which are between 0 and 2 pi, or 0 degree between and 360 degree, right? So now let's consider another example which is something different. Okay, so let's say this is negative. Well, not negative, 20, just a 25. Okay, so let's just say Garrett, can you read for us, please?
Find the reference angles of the following angles: 343 degrees, 25, and negative 370 degrees.
Okay, very good. Thank you. Okay. Now let's consider this one. Instead of 370 degrees, what I want is 443. How about that? Okay, 443. Okay, so can we find this one? Now you can see that for A, right? 443 is not between 0 and 360. Yes?
Yes.
So what shall we do? That's going to be our step 4, right? So got to find the coterminal angle that between 0 and 2 pi, right? So how do we do that? Add or subtract 2 pi or 360, right? Degrees, as many times as needed to find an equivalent between 0 and 2 pi. So for 443 is larger than 360, right? So what do we have to do? We got to subtract a full rotation, right? And see if it is if it is in between 0 and 360. If it is, then good. Otherwise, we do one more, right? So A, 443 degree minus 360 degree equals what?
83.
83 degree. And this 83 degree is already in what? In between 0 and between 0 and 2. 83, right? Which is in 0 and 360. This is already in, right? Then what is the reference angle of 83?
It would be itself.
It will be itself. It's in the first quadrant, right? So the reference angle of 83 is itself. Now, since it is in the first quadrant. Okay. Now, as we said, all right, that's the equivalent angle, right? So the reference for the angle, the reference angle of the equivalent angle is the reference angle of the angle, right? So therefore what? Hence, the reference angle of what? 443 degree is what? 83 degree. Because it's the same, right? It's the same as that. Okay. Now, all right, very good. Okay, so how about B? B is there is no unit. All right, so B is in radian. Okay, B is in radian. So can you find this one? Oh, is 25 greater than 2 pi or less than 2 pi?
Greater.
Greater. So you have to subtract 2 pi. And how many 2 pi's do you need? Right, so you may need a minus multiple of 2 pi's. 3? 3 times, okay. You try it, right? Try and see if you can find it. So 3, if it is a 4 2 pi, that's 8. Okay, you can see that. All right, so you may using the calculator, all right, and see. So 25 minus 2 pi, all right, equals, you can figure them out, all right, and see what it is. It's apparently greater than this one, right? And okay, so you can try this. Minus 2 times pi as 18 something, right? 18.7168 is greater than 0. Is greater than 2 pi, right? This is again greater than 2 pi. So we need to minus another 2 pi times 2, right? So and you can figure this one out, minus 2 pi times 2, and you got this is 12 something. Now this is again greater than 2 pi, all right? So then you do another one, right? 25 minus 2 pi times 3 equals. This one is 6.1504. Now this is what? Became less than 2 pi, right? It's less than 2 pi now, right? Okay, so the equivalent point is what? Hence, equivalent angle is 6.1504. Yes? Okay, that's the equivalent angle, which is within what? 0 and 2 pi. Okay, which is between 0 and 2 pi. So now, which quadrant is this in?
That'd be the fourth, wouldn't it?
It would be the fourth. Okay, so this one is 6.0 and it's greater than 3 pi over 2, right? So which is in the fourth? Quadrant, right? So the reference angle is
2 pi minus 6.1504.
very good, Hans. The reference angle is okay. You can just write this. Okay, you do not have to find this. The reference angle of what 25 is, all right, is 2 pi minus 6.1504. Okay, now you can just directly write the reference angle of 25, all right, instead of 6.15, this one, because they're the same, right? They're the same. So using the calculator, can you find this one? What is this?
0.1328.
0.1328. Okay, very good. Okay, that is the reference angle for 25. Yes. Okay, and can you find C, please? Okay, this is what I did right here. So because negative 70 is less than 0, so I need to add, right? Add 360. Now I got negative 10. It's still less than 0, so I need to add another 360, right? So I got 350 now. 350 is between 0 and 360. So 350 is in the fourth quadrant, right? In the fourth quadrant, so the reference angle is what? 360 minus 350, that is 10. Yes?
Yep.
Now, of course, I skipped some expressions here, all right? But you know the logic. You should know the logic. Okay, so how we got there here. Okay, so all right, so that's this example, right? So these two examples, based on these ones, we need to know how to find a reference angle given one, right? It's either between 0 and 360 or some other angles, right? So you need to know how to do that. And then we're going to use the reference angles to find sine and cosine. Okay, what do we do? Okay, given angle in a standard position, find the reference angle and the cosine sine of the original angle. Okay, so one thing we do is measure the angle between the terminal side of the given angle and the horizontal axis. That is the reference angle. So basically, one is just to find the reference angle, right? So in step one is try to find the reference angle. Two, determine the values of the cosine and sine of the reference angle. Now, the reference angle is always what? Between 0 theta prime, right? It's always greater or less or equal than 90. All right, it's always between, because it's acute. It's acute, All right, it's acute, positive and acute. So we have this equation, inequality. Now determine the value of the cosine sine of this reference angle. So which is pretty easy to know, right? So if there are special angles, we know these ones, right? Using the table we illustrate, we give here. Where? Okay, sorry, this one, right? If there are special angles, the sine and the cosine are given, right? From here. Now, if there are not special angles, we can use a calculator. Yes, we can use a calculator. So anyway, step 2 is no problem, right? No problem on step 2. Step 1, we learned. Step 2, okay, right? We know how to find the cosine sine of the reference angle, right? Now, step 3, give the cosine the same sign as the x values in the quadrant of the original angle. All right. Right. So for the cosine, you give the same sign as the x values because what? As we know, right? In a unit circle, now if the original angle is in the first quadrant, then they're all positive, right? X is positive, right? Now, if it is in the second quadrant, then X is negative. Yes?
Yep.
In the third one is also negative, and in the fourth one, X is also positive, right? So this is for the cosine, because cosine is the same as the sine of cosine is the same as the sine of the X values. Okay, so positive in quadrant 1 and 4, they are positive. In quadrant 2 and 3, cosine is negative. Yes? Now that's why we are give the cosine the same sign as the x value, right? Now in step 4, give the sine the same sign as what? The y value. Okay, so y value is in the first and second, they are positive, and third and fourth, they are negative. Yes? Okay. So basically, that's how we do so. All right. So 1 is to find the reference angle. It's between 0 and 90, right? 2 is determining the cosine sine of the reference angle, right? If they're special, we have the table. If they're not special, we can use a calculator, right? Step 3, for cosine, the same sign as the x value of the original angle, and for the sine, it's the same sign as the y value in the quadrant of the original angle. Okay, now let's consider example here. Okay, so let's see, Zhongxu.
Using the reference angle, find the exact value of cosine 150 degrees and sine 150 degrees.
Very good, thank you. All right, so let's do this one together. All right, solution. Now, 150 degree. Now, step 1 is to find the reference angle. So what is the reference angle of 150?
A 30.
Very good. Is 150 is in the second quadrant, right? Is the second quadrant. So say this equals absolute value of 180 minus 150. So equals 30 degree. Is 30 degree, right? So now the cosine sine theta prime is what? So hence cosine of theta prime equals cosine 30. Now what is cosine 30? Anybody remember? It's a special value, right? It equals what?
Is square root of 3 over 2. Or would that be?
Yes, very good. Square root of 3 over 2. All right. So and the sine is what? Sine is 1/2. Okay, the sine 30 is 1/2. Okay. Now, but we are to find the cosine 150 and sine 150, not the sine and cosine 30, right? So what is cosine 50 then? 150. Now since, okay, all right, so let me just do this one, all right? Since 150 is in the second, right? Second quadrant, so cosine of 150 is negative or positive?
Negative.
It's negative, right? Because in the second quadrant. So it is the negative cosine 30, right? As negative cosine 30 is negative cosine of the reference point 30 equals what? Negative square root of 3 over 2. And sine of 150, sine is going to be positive or negative in the second quadrant?
Positive.
Positive, right? Because in the second quadrant is the y values is above the x-axis, right? So y values are positive. So it equals what? Sine of 30 equals what? 1/2. Okay. So that's how we do so, right? So first we find the reference angle and find their corresponding cosine and sine values, right? And then depending on the quadrant this original angle is located at, we can determine the sine, right? So since it is in the second quadrant, cosine is negative, sine is positive. That's how we do so. Yes? Okay. Now let's consider another one. All right. Arinda, please.
Using a reference angle, find the exact value of cosine 5 pi over 4 and sine 5 pi over 4.
Very good. Thank you, Arinda. All right, let's do this one. And could you please go ahead and find this one out? Go ahead and see if you can find this one out. Okay, all right, some of us already got the answer. Did you get the same answer? Yes? Okay, let's do this one together, right? So firstly, the reference angle is what? As pi over 4. Does that make sense?
Mhm.
All right, so you see in the third quadrant, so C prime is the absolute value of pi minus this one is pi over 4. Okay, so therefore the cosine and sine of the reference angle, they are given here, right? Square root of 2 over 2, square root of 2 over 2. They are special angles, and you should find this one equals what? Square root of 2 over 2. Now, since pi is in the third quadrant, we have what? Cosine is negative, right? Cosine is negative in the third quadrant, right? Cosine is negative, so negative cosine for pi over 4 is negative square root of 2 over 2. Sine is also negative, right? Sine is also negative in the third quadrant. Right? In the third quadrant, y is also negative, right? The y value also negative, so it's negative sine pi over 4, which equals this one.
How did you get negative pi over 4 in the beginning? That's the only thing I need.
Oh, okay. So the reference angle, right?
Yeah.
Okay, so let's do this one together. All right. So
I did the pi minus 5 pi over 4.
Yeah.
And I got like a decimal.
Okay.
How do you
Yeah. Well, yes. If you use the calculator, you will got a value like that, right? So, but for this one, since it is a multiple pi, so you can do, what you can do is the pi minus the 5 pi over 4. You can write as what? 4 pi over 4 minus 5 pi over 4.
Okay, that makes sense.
Yeah, and then since they are the same denominator, on the top is 4 pi minus 5 pi is negative pi, right? So that's how we got this. Very good question. All right, thank you. Okay. Does that make sense? Anybody else? Good? All right, so very good. And use the reference, find the coordinates. Okay, so given the angle of a point on a circle and the radius of the circle, we want to find the xy coordinate of the point. All right, so what we do is find the reference angle by measuring the smallest angle to the x-axis. So this is again using the reference angle, right? So find the cosine sine of the reference angle, determine the appropriate sign for x and y in the given quadrant. So here, I want to say that the radius is r, then the this angle is t, all right, is t. Then in this case, actually my x is going to be r cosine t, and y equals r of sine of t. Okay, so this is the general formula for this type of questions. All right, r equals cosine, x equals r cosine, y equals r sine. All right, so in other words, this coordinate, this may not be a unit circle, right? So this may not be a unit circle. So the sketch is bad. Sorry. So in this case, the radius is r, right? If the radius is r, then you can just do this one, okay? So, but for sine t and cosine t, you can find the reference angle, right? You can use the reference angle to find a cosine sine, and then determine the sign for x and y and so on. You can find out that one out, okay? Well, I think it's already time. All right, Mustafa, you have a question? No, okay, all right. So I think this. Well, sorry about it. In the future, in the past, I believe I thought it was the class ends at 12:15, but I just figured it out. It ends actually at 12:10 instead. All right. So I'm very sorry for the past several classes, but in the future, we are going to stop at 12:10. All right.
Yeah, it's fine.
Okay. All right. I think that's all for today, and.